All right, welcome to what might be one of the more important lessons concerning percents, and it is working with decimals and percents. So in this video, we're going to be looking at how can you go from a decimal and convert that into a percent, and then how could you convert percents into decimals. And you know what, we'll probably slip in some fractions in here anyway because they're all related. When we're talking about fractions, I'm going to say a fraction or a decimal, converting it to a percent. Because when we're talking about these, we're discussing quantities in relationship to 100. So you have to go back to this idea that percent is like saying for each 100. Or we've defined our whole is going to be equal to 100. So no matter what quantity we have, even if it's like a 3 to 4 ratio or 3/4 as a fraction or 0.75, 75 hundredths, we are going to be converting that into some sort of an equivalent value with a basis of 100. And so here's where we see this idea, well, of if our whole is 100 and when we talk about especially this fraction, these two things here, these are going to be less than one whole. So we're dealing with parts that are less than one whole for right now, because we obviously can have more than 100%, but we'll get to that in a moment. So to start this out, we'll be thinking about, okay, if we're dealing with a fraction like 3/4 or a decimal like 75 hundredths, and we know those are parts that are less than one whole, but that whole is made up of 100 parts, because we're talking about percent, that must mean that each part has a value of 1/100th. 1/100th. So this idea of our whole is going to be of 1/100th. Now that, if we know that each part has a value of 1/100th, that means if we have 100 hundredths, or that as a fraction, 100 hundredths, you might be hearing Wrigley whining in the background, I apologize. If we have those two values, 100 hundredths or 100 hundredths as a fraction, these both have a value of 1.00. Or if you look at this, it looks like it's a 100 that ends in the hundredths place. So all of this is related in a really kind of intricate and fun little way, where when we look at something like convert the decimal 75 hundredths into a percent, well, we could think of that like it's 75 100ths as a fraction, and I know that because this is per 100 percent, this is going to be 75%. And this is pretty straightforward when you have easy ones like this, or like 3/4. If we look at this fraction and we want to turn it into a percent, something per 100, I know that we can multiply by 25 because 4 times 25 is 100, 3 times 25 is 75, so this is 75%. So that should be pretty familiar. And with these really simple ones, it is pretty straightforward. But not all percents are going to be nice and straightforward. So if we're dealing with a decimal, that is, I guess it's probably more difficult with a fraction turning it into a percent. But if we look at a decimal, let's say it is like 39 hundredths. So we know that this is per 100, so this is 39 100ths. And so you might be able to look at that and just say, okay, great, that is 39%. So mathematically what you're doing is you're saying 39 out of 100, and we know that is going to be times 100%. And when we put that little percent sign in there, that's a really crucial thing, because in your mind, you should be thinking that 100% is equal to 100 over 100, and that has a value of 1. So if we multiply by 100%, then that means that we're just multiplying by 1, so it's not changing the value at all, it's just changing the way that it looks. And if I simplify before I multiply, zoop, zoop, I now know that I have 39, that percent sign is still there, percent. And so this little tricky bit here can become really helpful when your fractions or your decimals are less friendly. So let's say you have a word problem that is something like 33/40ths, and we need to turn that into a percent. So we have 33 chairs are blue out of the 40. What percent are blue? So if we use this idea up here, well, let's multiply that by 100%. And I'm keeping that percent sign there because that tells me I'm not changing the value at all. I'm going to simplify, and I know I can divide by 10. And now I can divide those both by 2. So that would be left with a 2, and that's a 5. So now I'm solving 33 over 2 times 5. And when I multiply that, I get, well, 5 times 3 is 150. 5 times 30 is 150. 5 times 3 is 15. So we have 165 halves. And now that we have 165 halves, I could use this like division because I know that that is equal to 165 divided by 2. And, well, if I'm going to do that division, 165 divided by 2, 2 goes into 1 0 times, 2 goes into 16 8 times. Bring that 5 down. Now, wait a minute. 2 goes into 5 4 times. No, 2 times. My bad. Oops, and that's 4. So now we're left with 1. But I know that if I'm thinking of this like it's 165, which I am, it's 165, but I still have one whole left. I know that if I add a decimal point there, I'm not changing the value of it at all, but I do know that this one whole is equal to 10 tenths. And 2 will go into those 10 tenths. I think of it like 10 tenths. It'll go into it 5 times. And 2 times 5 tenths is 10 tenths, or 1 whole. And we're at 0. So we know that this fraction as a percent is 82.5%. I'm going to do one more of those. Actually, I'll set up the problem, let you pause the video and see, can you work your way through it following these steps of step 1, let's multiply it by 100%. Step 2, let's simplify before we multiply. Simplify. Step 3, multiply. And then step 4, you will likely have to divide. So yes, let's do that, and then we'll break this apart just a little bit more. So your example here is Mr. Plaska ate, let's say 15, or he had 15 cookies, and he ate, I'll write this out, had 15 cookies, and he ate, that's supposed to be a D, he ate 6 of them. What percent did he eat? So, pause the video and see if you can solve that following these steps up here. I'll zoom out so you can see them. All right. So if we're going to follow these steps, first multiplying by 100%. So I know that I ate 6 out of 15. So I'm starting there. And I need to multiply this by 100%. And again, why we can do this and it doesn't change the value is 100% has a value of 100 out of 100 or 1. So we're not changing the value, we're just changing the way that this number looks. And we can do some simplifying. So first I'm going to divide by 5. And I know 100 divided by 5 is 20, and 15 divided by 5 is 3. Now I can't simplify that anymore because 3 and 20 don't go together, but I know 6 divided by 3, or 6 over 3, and that's 20. And so I have two options here. As I look at this, I know 6 divided by 3 is 2, so I could just do 2 times 20, and I get 40%. Or I could do I could multiply across the top and get 120 over 3, which is 120 divided by 3, and I know those are 12 tens divided by 3, so that's 4 tens, or 40%. So I ate, Mr. Plaska ate 40% of his cookies. And that is a pretty realistic problem. So here's how you can see that these steps of let's multiply by 100, we can simplify, multiply, and then divide if necessary, can work out for a lot of other problems. But I mean, ideally, if you're able to put it into a fraction with a denominator of 10 or 100, or especially 100, then you should be good to go. So that is looking at fractions or decimals, fractions or decimals into percents. So now if we look at percents into fractions, that one is going to seem pretty familiar to you, I hope. Where if you have, we'll start out with an easy one, 50%, I know that means 50 out of 100, and then I can just simplify that fraction, and I know 50 out of 100 is 1/2. So when you're converting fractions into, or percents into fractions, always in simplest form. So always simplify. Always, always, always. So step 1, we turned it into a fraction with 100 as the denominator, and then step 2, we simplified. Now let's say you're talking about the growth of something and it grows 125%. If we turn this, we can convert this percent into a fraction. We will do the same steps, 125 out of 100, and I know that that is equal to 1 and 25 hundredths. And then I know I can divide both of these by 25, so I can definitely simplify, and I get 1 and 1/4. So here you can see how this works with any sort of percent, whether it's greater than or less than a whole or a 100%. So hopefully percents into fractions is a little bit more straightforward than oddball numbers into percents. But if we look at percents into decimals, this one, let's see. Let's say, again, we have 75%. And so 75% is 75 100ths, or 75 100ths. Pretty straightforward. If you know anything about fractions and decimals and the relationship between those things, should be easy peasy. So this works even if it's something like, what if you have 1.2% and you need to turn that into a decimal? So that means you have 1.2 out of 100. Now, having a numerator that has a decimal in it isn't really great. And so I know that if I multiply these both by 10, this will move over one place and it will add a 0 at the end there. So we would have 12 thousandths. And 12 thousandths, that sounds like a decimal that I know. This is a 12 where that has to be the thousandths place. So that's the hundredths. So we need the tenths. And there we go. We have 12 thousandths. So you could convert this percent into that decimal. And this works also with percents that are greater than 100. So if you have 368%, that means you have 368 100ths, or 368 that ends in the hundredths place, so my decimal point must go there. And I think that seems pretty reasonable, because the value of our ones place is 3, because we have 300%. We have 3 of those hundreds, and our hundreds is a whole, and so we have 3 wholes. Easy peasy. Easy peasy. Now you might be wondering, there's a shortcut here, Mr. Plaska, where if I look at this and I say, I know that this is the same as 368 divided by 100, and so that means I can move my decimal point 2 places over, and I get 3 and 68 hundredths. And yeah, that would be true. Even up here, if you turn this fraction into a division problem, you have 1 and 2 tenths divided by 100, so because we're dividing by 100, it needs to move to the left 2 places, so we get 0.012, or 12 thousandths, which is what we got here. Either way works. And it looks like if you turn it into a fraction first, it shows why that straightforward way works. So that is dealing with percents into fractions and decimals when they're not super friendly, when they are not the easy peasy ones.